Okay, Assalamualaikum. Today I'm want to presenting about sequence and series. Okay, this is our group members. Okay, first introduction. Introduction of sequence. Sequence is a list of item or object which have been arranged in a sequential way. A sequence is an arrange of any object of a set or a set of number in a particular order followed by some rules. Each number is the sequence is called a term. Sequence term, Xn is the term, n is the term number. Okay, for the series is the sum of all the term in an infinite sequence. When you add the term of a sequence, it forms a series. Sequence has two types. First, arithmetic sequence. Arithmetic sequence is a sequence in which every term is created by adding or subtracting a definite number to the preceding number is an arithmetic sequence. This is the formula. A is the first of term, n is the position of term, d is the difference between the term. Okay, next, geometric sequence. Geometric sequence is a sequence in which every term is obtained by multiplying or dividing a definite number with the preceding number. Is known as a geometric sequence. This is the formula. A is stand for first term. R is the factor between the term. Okay, next we have series. Series also have two types. First type is arithmetic series. Arithmetic series is an arithmetic series is the sum of the term in an arithmetic sequence. In an arithmetic sequence, each term is obtained by adding a constant difference to the preceding term. This constant difference is called the common difference. This is the formula. Sn is stand for the sum of the first n term. N is the number of term. A is the first term of the sequence. An is the n term of the sequence. Okay, next, geometric series. Geometric series is the sum of the term in a geometric sequence. The formula depends on R values. Sn is the sum of the first n term, n is the number of term, a is the first term of the sequence. R is the common ratio between consecutive terms.
The chicken reject our arithmetic problem, which is the fact is Encik Suhaimi have 1,500 chicken. He feed all the chicken with spending 50 cents per day. He want to sell 200 chicken every day. How Encik Suhaimi manage the total cost of the chicken expenses allocate starting from the 1,500 available chicken to the remaining 300 chickens. So the action is we can write up in internet and using reference book or distribute to the other customer or using the arithmetic progression. This is our Pila table for geometric problem. The fact is, Mr. Muslim saving 40,000 ringgit into his newborn son's account bank. The bank offers 5% interest per year. He needs to bank in money into his son's bank account consistently. The idea is Mr. Muslim wants his funds to reach 30,000 ringgit when his son is 18 years old. The learning problem is how to ensure that Mr. Muslim's savings for his son can reach the savings target. And how can Mr. Muslim saving reach 30,000 ringgit if the interest is reduced to 3% per year after 10 years? The action, we use the geometric formula to ensure that Mr. Muslim reaches the target or not. And by references website, also by references book.
So let's move to the problem background and solution. So the question is about the chicken breeder, and we solve it with arithmetic equation. So the question is, Encik Suhaimi have a 1,500 chicken. He feed all the chicken with the spendings RM 50 cents per day. He want to sell 200 chickens every day. How Encik Suhaimi manage the total cost of the chicken feed expenses allocated starts from the 1,500 chickens available to the remaining 300 chickens. So, step first, we start from arithmetic progression and we list the total chicken until 300, and we found the first mention A, which is 1,500 chicken, and common difference is negative 2,200. So uh and we calculate, we got on 7 day the number of chicken is left is 300. So the total cost of food expenses that Encik Suhaimi have to buy is RM 3,115.
The solution for future planning situation by using geometric sequence. Mr. Muslim started saving 14,000 ringgit into his newborn son bank account. The bank offered an interest of 5% per year. Mr. Muslim hopes that the saving his son will reach 30,000 ringgit when his son is 18 years old. From this question, the bank give interest every year is 5%. Okay, the first term we get a 14,000 ringgit, but we don't have the value of R. So we need to use R formula, which is xn plus 1 over xn. Insert the value and we can get R is 1.05. After that, insert the R value into the geometric sequence formula. After that, bring 14,000 ringgit into the other side to be divided. And then use the log principle to bring the power of x minus 1 into front. After that, bring log 1.05 into the other side to be divided. After get the answer, bring minus 1 into the other side, and then we can get the final answer for n is 16.62. So the conclusion is the saving of 30,000 ringgit can be achieved before Mr. Muslim son is 18 years old.
So we move to the last part of presentation, which is discussion and conclusion. So first we look at discussion. Okay, for the discussion, from the solution we can know an arithmetic sequence is a sequence of numbers in which each term and term after the first is obtained by adding a fixed constant to the preceding term. This constant difference between consecutive terms is known as the common difference. A geometric sequence is a sequence of number in which each term after the first is obtained by multiplying the preceding term by a fixed constant known as the common ratio. An arithmetic series is the sum of the term of an arithmetic sequence. It is obtained by adding up the terms of a sequence, where each term is derived by adding a fixed constant. The common difference to the previous term, a geometric series, is the sum of the terms of a geometric sequence. It is obtained by adding up the terms of a sequence, where each term is derived by multiplying the previous term by a fixed constant, the common ratio. So next, we look at the conclusion. Arithmetic sequence and series involve linear progressing with a constant difference between terms, whereas geometric sequence and series exhibit exponential growth or decay with a constant ratio between terms. In essence, arithmetic sequence involve addition of subtraction of a constant value to obtain subsequent term, leading to a linear progression. In contrast, geometric sequence involve multiplication or division by a constant ratio, resulting in exponential growth or decay as the sequence advance. These concepts are not only fundamental in mathematics, but also find application in various fields, including finance, physics, biology, and engineering. Understanding arithmetic and geometric sequence and series enable uh, use to model real-world phenomena, make prediction, and solve problems in diverse areas of study. Their versatility and applicability highlight their significance in both theoretical and practical contexts within mathematics and beyond. So that's all from our team. Thank you.